Ever wondered about the number of bones that make up your body? Well, the human skeletal system is an incredible network of 213 bones. Yes, you heard it right, 213. These bones are categorized into two main types, the axial skeleton and the appendicular skeleton. The axial skeleton, which forms the central core of the body, comprises 74 bones, including the skull, vertebrae, ribs, and sternum. On the other hand, the appendicular skeleton, which includes our extremities, consists of 126 bones. But wait, that leaves 6, doesn't it? These are the auditory ossicles, the tiny bones in our ears that help us to hear. So from the top of your skull to the tips of your toes, each bone has a specific role in supporting, protecting, and enabling our bodies to move. So that's 213 bones that literally hold us together. Did you know not all bones in your body are alike? Indeed, our body's skeletal framework is made up of two distinct types of bones: compact, also known as cortical, and cancellous, or woven. Compact bones, resembling ivory in appearance, are incredibly robust and densely packed. These are primarily found in the diaphyses of long bones. They provide the strength and structure our bodies need to perform daily activities. On the other hand, cancellous bones, with their loosely woven lattices, are less densely organized. They're typically found in the metaphyses and epiphyses of long bones. Unlike their compact counterparts, these bones are designed for flexibility, absorbing the stresses and strains that our bodies undergo. So, compact bones for strength, cancellous bones for flexibility, each uniquely tailored to the demands of their location in the body. The next time you think of bones, remember, they are as diverse as they are vital. Bones can be classified based on their anatomical and structural characteristics. There are 4 primary classifications: long, flat, short, and irregular bones. Long bones, as the name suggests, are longer than they are wide. They are primarily responsible for our height and the general shape of our body. Examples include the clavicle, humerus, radius, ulna, femur, tibia, and fibula. Even some bones in our hands and feet, like metacarpals, metatarsals, and phalanges, are considered long bones, though they might be referred to as short long bones due to their smaller size. Flat bones, on the other hand, have a thin, flattened shape and are often slightly curved. These include bones like the skull, mandible, scapula, sternum, and ribs. Their main function is to protect our vital organs and provide a surface for muscle attachment. Short bones are approximately equal in width, length, and thickness, providing stability and some limited motion. Examples are the carpal bones in the wrist and the tarsal bones in the foot. Irregular bones are all the bones that don't fit into the other categories due to their complex shapes. The vertebrae, sacrum, coccyx, and hyoid bone are examples of irregular bones. Focusing on long bones, they have a specific structure composed of a central shaft called the diaphysis, flared ends called metaphyses, and rounded extremities known as epiphyses. Inside the bone, there is a medullary cavity that houses bone marrow. So the diversity of bones goes beyond just their type and location. Ever heard of the periosteum? It's more important than you might think. This fibrous connective tissue sheath wraps around the outer cortical surface of our bones, much like a protective blanket. Interestingly, it excludes joints that are lined by articular cartilage. The periosteum is a busy little structure. It's sustained by small vessels that supply a significant portion of its blood. It's anchored in place by Sharpie fibers, fine threads that attach it securely to the bone. And it's a bustling hub of activity, housing blood vessels, nerve fibers, osteoblasts, and osteoclasts. One fascinating aspect of the periosteum is its thickness, which tends to be more pronounced in children than in fully grown adults. It's a crucial player in maintaining healthy bones, offering nourishment, and protecting the underlying cortical bone. It's particularly vital for bones close to the skin, like the tibia, where injury or exposure without periosteum can severely affect their survival. Moreover, the periosteum promotes the growth and remodeling of bone, a process that becomes increasingly crucial as we age, and bone resorption starts to outpace bone formation. The periosteum is truly the unsung hero of our skeletal system. Joint injuries can have a significant impact on our skeletal system. There are 2 types of injuries we should be aware of: articular and diaphyseal. articular injuries extend into the joint space, disrupting the articular cartilage that plays a crucial role in smooth joint movement. Diaphyseal injuries, on the other hand, affect the bone shaft but can still compromise joint function. Both types can be detrimental to our mobility and overall quality of life. Remember, taking good care of your bones and joints can save you a lot of trouble in the long run.